A centrifugal pump looks simple from the outside. A motor turns a shaft, water enters the pump, and water comes out under pressure. But what actually happens inside that metal casing? In the next few minutes, we'll take the pump apart and see exactly how it works. A typical centrifugal pumping system has several important components. The electric motor provides rotational power. The shaft transfers that power to the impeller. The impeller accelerates the fluid, while the pump casing converts part of that velocity into pressure. Finally, the discharge pipe carries the fluid to where it is needed. The heart of a centrifugal pump is the impeller. As the impeller rotates, fluid enters near the center, called the eye of the impeller. The rotating blades then move the fluid outward. The fluid gains velocity as it travels from the center toward the outer diameter of the impeller. But high velocity alone is not enough. The pump must convert part of that velocity into useful pressure. That is where the casing becomes important. In a typical centrifugal pump, the volute gradually collects the fluid leaving the impeller and directs it toward the discharge outlet. As the flow area changes inside the casing, some of the fluid's velocity energy is converted into pressure energy. This allows the pump to deliver fluid against resistance and elevation. Now let's look at the suction side. The pump needs a continuous supply of fluid. Restrictions in the suction pipe, excessive lift, air leaks, or an incorrectly sized suction line can reduce the amount of fluid reaching the impeller. One of the most common and destructive problems on the suction side is cavitation. When local pressure drops too low, vapor bubbles can form inside the liquid. As these bubbles move into higher pressure areas, they collapse. Repeated bubble collapse can create noise, vibration, surface damage, and eventually serious impeller erosion. The rotating assembly also depends on the shaft, bearings, and mechanical seal. Bearings support the rotating shaft and help maintain alignment. The mechanical seal helps prevent fluid from escaping along the shaft. Problems in these components can lead to vibration, leakage, overheating, or premature failure. So why does a pump sometimes fail to deliver the expected flow or pressure? The cause may be surprisingly simple. A blocked suction line, worn impeller, air entering the system, incorrect rotation, damaged bearings, or an operating condition outside the pump's design range can all reduce performance. Before replacing an expensive pump, diagnose the system. Check suction conditions, discharge pressure, flow, motor rotation, vibration, temperature, and signs of leakage. Compare the actual operating condition with the pump manufacturer's performance curve. A good diagnosis can prevent an unnecessary replacement. So, in simple terms, a centrifugal pump works by transferring rotational energy from the motor to the impeller, accelerating the fluid, and converting part of that energy into pressure. Understanding that process makes troubleshooting much easier. If you want to understand how industrial machines really work, subscribe to Machine Logic. More practical engineering explanations are coming.